Welcome, everyone. Session is about the Crosswork HCO, which you've heard about from Rana, from Paula, and others. I would like in this session actually to spend some time on giving the background on the HCO. What is the Crosswork Hierarchical Controller? And then also talk about the VPN, what's in the title as the Unveiling the Secrets, the optical circuit. Well, there are no secrets, but we will discuss how HCO actually provides you the view of the VPN and the assurance of the VPN, which is beyond what you see in the IP layer. It goes also to the optical layer, and I think this is an essential part of what we have in HCO. So we're going to have the HCO in brief. I would like to talk about the use cases. I mean, when customers will need HCO, for what purposes, what's in there, talk about the features, the functions. And then, as I said, I would like to start with the IETF standards for the L2 and L3VPN. Speaking a little bit about the provisioning process, how it goes from HCO and then the assurance, and to sum up with the status and the timeline. And we have time, so I would like in that point or others to extend beyond what we have in slides. And since we're a few in the audience, then you can feel free to interrupt me, ask questions, and we can make it collaborative, which I think will be even more interesting and helpful for you, or after lunch at the end. So, okay. Starting with what's the purpose actually of the HCO. When we look on the core network, the transport network, there are actually silos, different networks. There is the IP core, IP aggregation, optical, and normally in most of the cases, there is no single optical network. There are multiple optical networks by different vendors, and each system has its own operational system, like NMS or SDN controller, sometimes scripts, homegrown systems, but at the end, there are different systems. And when there are cases in which you would like to know what's the situation in the IP network, whether the source of a failure is in the optical network, and the fact that I don't have resources, could it be that I might have more resources if I would increase my optical network? Many, many questions that you don't really get answers on unless you use people, human, to interact, to exchange information by emails, by files, by discussing with each other, which, as you can imagine, takes time, sometimes prone to errors, and there is no system that actually collaborates them all together. That comes HCO, and it started like 7-8 years ago in a small startup called Sedona, and we're 20 people with a great idea. Why cannot we actually automatically discover the points between the IP network to the optical network? Meaning at the end, when we look at this connectivity, the physical connection between the networks, this is an Ethernet link between a router, goes to the transponder in the optical network. And they have developed an algorithm which automatically discovers which port in a router is connected to the port in the optical network. And by that, actually built a system, which originally called NetFusion, in which the networks can be discovered. The IP network can be discovered from different sources. The optical network is being discovered from NMSs, from the SDN controllers, and created together a holistic picture of the network, multi-layer, multi-domain picture of the full network, which is a golden source of information. And you can just imagine, once you have this view, what you can do with this view: analytics, assurance, provisioning, and many other use cases. 3 years ago, we were acquired by Cisco and became part of the Crosswork family as the hierarchical controller, which actually fit into the architecture that is not something proprietary by Cisco, but this is the standard in the industry. So we can see several standard bodies who actually define the architecture of the SDN network, starting with the IETF, in which you can see that there are different names here are not the same as we use in Cisco, because you can see here the CNC on top, where this CNC is actually the customer network controller, meaning the service orchestrators or the OSSs, and you can see the MDSC, the what we call the HCO. It's is a centralized point which connected to all the domain controller entities which are actually controllers. And you can see the same for the ONF TAPI. TAPI is an interface between optical controllers, which actually started in an organization called ONF, which doesn't exist anymore. And now the TAPI definition moved to the Linux Foundation. So, but TAPI is I think the de facto interface from optical controllers to the HCO, which is adopted by most of the world service providers and all of the optical domain controllers vendors, actually. So we're aligned with that, as well as with the L3GPP, where the network function, network function which is actually communicating with the transport network, is the hierarchical controller. And I think the most relevant one is actually the TIP. TIP is the Telecom Infra Project. It's an organization started almost 10 years ago by Facebook, when they realized that when they look at the optical network today, it's a kind of a black hole in their system. It's normally a single vendor that provides you everything. For those who are familiar, there is a ROADM, there's an amplifier, transponder, and there is a single optical network that provides you all these systems with its own, in most of the cases, with its own NMS or SDN controller, and you're locked to the vendor. I mean, you cannot touch it. Normally, this vendor provides you also the planning tools, the assurance tool, everything about the optical network. And as a result of it, prices were going high, and there was kind of a stickiness between the vendor to the operator. What TIP did, led by Facebook back then, is to define what they call optical disaggregation, meaning that why getting it actually from a single vendor? Why not opening this up? I would like ROADMs to be bought from, say, Sienna, for example, and I would like the transponder to be from Cisco, Adva, Infinera, whatever. And there were some projects in which some operators successfully implemented and deployed interface disaggregation optical network that creates challenges, because it's unlike the IP where you have CLI, SNMP, OpenConfig, many interfaces that are open. You can connect them to any system. It's not the same in optical. In most of the cases, when you go to an optical device, it has no standard interfaces that you can connect with. There were, back in time, for those who remember, there were TL1, for example, and some SNMP MIPS, but in the optical network is very basic, very pure, that you cannot really count on that to build your own system and easily manage an optical network. So an optical disaggregation created those challenges of management that we in HCO actually got straight into it, because unlike many other systems, and I think this is the value of the HCO, what we have is a system that is already deployed by many of the world leading service providers. And we did integration already with optical systems, it wasn't easy to get integration. And I can tell you that in some of the cases, we realized after we started the integration that we were the first ones to integrate with these systems. And currently, we covered most of the leading vendors. We have Sienna, Huawei, Nokia, Infinera, also with the Adva we're about to start. So we have all the vendors actually supported, and we have the multi-layer actually covered. So we don't not only having the optical systems, but also the IP layer on top. And if I look at the role of the HCO in the in the automation ecosystem, then we see that there are SDN controllers for IP by all the IP known vendors, SDN controllers for the optical, and also for the microwave, which is not yet being implemented, because if you look at the microwave equipment today, there are NMSs, but there are no SDN controllers, meaning aligned to the standards of ITF or TAPI. We see very initial implementations, but it's very early days. Once there will be, probably we will be the first ones to integrate into the system. what's the value of HCO? I think you have seen this slide in Paola's presentation. What we actually have is what we call service to fiber layers, service to fiber visibility, because we have the discovery of the VPN services, the IP layer, the IP topologies, the optical topologies, and in some cases we also have the fiber facilities being discovered. It depends, of course, on some local integration from proprietary systems, but we have a capability to do so. And once this is discovered, then you're able to see the full stack of the network. And we have many tools that were developed in order to visualize these multi-layer paths. You can see this, which is kind of a metro view, where when you have a link which is down, you can see all the layers through the fiber, and you can see easily where is the link that actually caused all the stack to be failed. So you can see that by color in the tree. There is a 3D view of all the links where you can see by different colors. You can see the IP links, the optical links, and all the layers, and also a satellite view. So in many of the cases, and we have an interesting case which runs now by one of our customers, we discovered the fibers, and we also have an application to detect cases where there is a proximity, where two fibers are actually too close to each other, which means that if there will be something happen in the area, you're actually risking two fibers in a single point as a single point of failure. And in many cases, you can imagine what's the impact of it, because what if you have upper systems like IP with a protection path that you're sure you have 1+1 protection or restoration or many methodologies, but at the end, those two paths are actually on two fibers that are in a close proximity. Single failure can take them off. So we have a system that automatically detects that, and being able also to generate those violations into the provisioning systems. So they can treat it as SRLGs, for those who are familiar with that, meaning these are shared risk. Try to avoid using those two links for the same provisioning, for the same service or same tunnel. And other applications, like, for example, getting all the inventory, which is a very good source of truth for the inventory of the network, including not only the topology links, but also cards, pluggables, power supplies, fan units. Everything is being discovered, being modeled into the holistic network model. Applications to analyze failure and to simulate failures, like the failure impact in case of a coordinated maintenance. You're able to go to the system and ask questions like, what if I take this optical device down for maintenance for 2 hours? What will be the impact? Which IP services will go down? And do you have any alternative path for them? For example, others like root cause analysis. There was a fiber cut. Which services were impacted? Which MPLS tunnels or SR tunnels went down? So I need now to think about how to prioritize my recovery plan for such a failure. So these are applications that you can see in the UI, and also APIs that are exposed. Because in most of the cases, and I think you've seen the presentations on the assurance, where the world of assurance is very big, starting from the systems like Splunk and Thousand Eyes, down to the Accidian and down to the controllers, where we see HCO as a component which is part of it, meaning we contribute the multi-layer aspect into the assurance systems. So once you have this information and you have a failure and you detect a failure, you know that your service now is being degraded. But you ask yourself, what is the reason for that? What is the root cause for that failure? And easily, if you get a multi-layer aspect, you would know that a failure, a fiber cut that happened in the night is probably the culprit for this failure in the IP network. And normally, if you don't have such information, it takes days to do the correlation between the two. But here, you get it in minutes, which is a big difference. Use cases, or in other words, what are the cases in which customers would approach us and would like to purchase HCO and see the value of HCO? So what we see now is we have 3 of them. The first one is the RON automation. You've heard about the routed optical network, which Guru spoke about. So HCO is the automation solution for the routed optical network. There is the multi-layer IP optical, which is a classical case of getting discovery of the IP network, the optical network, and being able to provide a holistic view for the full network. And also the multi-domain optical, which is in case you have several optical domains by different vendors, and you need a holistic view of all of them. Then you can see the optical link traversing from one vendor to another in the same system. Starting with the first one, so before we talk about the value of HCO for the routed optical network, let's understand the value of routed optical network. Starting with the economics of the optics as pluggables that replaces standalone boxes, transponders in a network, which is a huge save in cost, in operations, and the total cost of ownership throughout time. And we see an increasing demand of optics versus hardware when it goes to higher rates. And we see an evolution of systems as it goes from data center to metro to long haul, moving from those boxes to pluggables. And in a time, we see a big opportunity for Cisco to increase the market share on the optical network when it comes to pluggable versus standalone boxes, because there is, of course, the benefit of having already the routers there, and you have already the routers with the operations, with the power, with everyone knows about how to operate a router. So it is a natural part of getting these pluggables into the routers. Now, when we look at the network view and the role of the HCO there, then we have the optical controller, the optical network here, and an optical network here, and an IP, and they're all layered. So when you get a view, actually you have routers with the pluggables. They are connected to each other. There are a wavelength between the routers, meaning actually between the pluggables, okay? And these are connected to a third-party, potentially microwave network. And it's complex. And if you want that to be visualized and to have a single view, or what we call a single pane of glass for the full network, then you need HCO for it. What do we provide in HCO for this solution? Then starting with the topology visualization. So we show the ZR Plus. ZR Plus is actually as a technology that gets into the pluggables, into the routers. Because to give us some background of that, when you look on the optical network, you have different technologies. There is the photonic network, okay, in which boxes traversing lights between the boxes, okay, and they are getting actually cross-connecting lights from one box to another and being able to transfer traffic. You can consider that as a highway, okay, all based on light, no digital no digital packets there. It's just the fibers, okay? And then there are the transponders, which actually converts the light into digital signals. And that technology that converts the light to digital signal, okay, it's a layer 1. If you look at the network layers, it's a layer 1. And it's actually the layer below Ethernet. And the box who actually does that translation, that conversion between the photonic to the digital is a transponder. Now, normally, if you go to optical networks today, you find those transponders as standalone boxes or as a card in an optical device. Pluggable with a new technology called ZR, which goes up to 400 gig, in the future even higher than that, is a small form factor, this size, gets into a router and replaces the standalone box. So you can imagine the saving in terms of costs, in terms of operations, in terms of power. So here in HCO, what we have is that we show the topology with the router and the IP links between the routers, but we show also the layers. So you can see the link between the pluggables, which is not an IP link. It's actually an Ethernet link and the ZR link. This is the technology. It's called ZR. Okay, and then we're showing also how the optical network is connected between the ZRs. Because you can imagine that when you have your road with a car from your neighborhood and you want to go to another neighborhood, you go to the highway. So the full path of your trip from house A to house B, starting with the small roads, okay, neighborhood roads, to the highway, and then again to the neighborhood small roads. We show the full path. So you can see now where the traffic goes now, and you can imagine that if there is a failure, then this view is very much important to show you how actually you can troubleshoot that. What if you have some example of failure in small optical box somewhere? How does that affect my IP network? So once you have a view that includes all this span, you can imagine how easy it is now to detect and easily actually repair the failure. So starting with the topology visualization, then we go to the assurance, meaning not only visualizing the path and the layers between the boxes, but also reading the performance metrics from the boxes. And each box, its technology with a different metrics. So when it comes, for example, to packet, then I have to read the in and out packets and the draw packets. But when it comes to a photonic network, I have to read the power. The RX power, meaning the receive power in one side, and the transmit power, in one side, and the receive power in the other side. And if there is a degradation in power, I know there is an issue. I know there is a failure there. And I would like to highlight this in the UI. So when you look at the full span of the link from router to router through the optical layers, you can easily see that there is an optical power degradation at some point, which is the root cause for failures in the upper layers. Going also to the link provisioning, meaning that using HCO, you can provision a link between the routers over the ZR pluggables and also implicitly configure the optical network in between. So you don't need to go to different systems and deal now with papers, writing the spectrum here and the spectrum there and the frequencies. You just open the wizard in HCO and you can, within a few clicks, configure all the links through different systems, which saves you a lot of time and avoid all the errors in between. And it's something very important to understand about the architecture of the HCO. Then HCO is a product that you can install and deploy, but you need adapters, similar to NEDs that you need in NSO, which are kind of drivers that connects the NSO to other systems. In HCO, you have adapters, meaning you have those pluggables that you need in order to communicate with different systems. So we developed the adapter, and we provide the adapter as part of the product. We developed already those adapters, of course, for the Cisco CNC, the optical controller. In case there is no CNC there, we have a solution, what we called the drone starter kit, meaning you can put the HCO there, and we can communicate directly with the routers. And for the OLS, which is the optical line system, we have the Cisco ONC in case you have the Cisco optical network, or we are connected already to Sienna MCP. Now we are in progress also to build adapters for the Nokia optical controller and the Huawei optical controller, which if I look on those three, including Cisco, it covers 80% of the optical networks today. Coming to the second use case, which is the multi-layer IP and optical. As I explained before, this is the typical case in which we have an IP network, we have an optical network, and we can show you how these are connected together. We show you a holistic picture of the full network, starting from the visualization and analytics of the full topology, including also a multi-layer root cause analysis application, and including the failure impact analysis, and dealing with the crosslinks, which is something important. If you remember at the beginning of the talk, I spoke about the algorithm to detect a link between the IP and the optical network. Now, this algorithm is very important. It's part of the solution, but it requires, in many cases, our engineers, because in a few words, it's about getting the performance counters in one side, getting the performance counters in another side, and create some pattern of the behavior of the link and find a match between the patterns, which leads to 98% accuracy of the matching between the optical port to the IP port. But in many cases, in order to get this running, we need to fine-tune the performance counter, the performance files, because you can imagine that you need the real-time clock in all of the boxes to be exactly the same. And sometimes there are some invalid intervals of traffic that you need to remove them from the equation. So we have a solution which is based on auto discovery, but we have another solution which is based on files that you can, maybe you have a source of those connections. We provide you an API to connect the two together. So also we have the fiber facilities. So if you have the fiber, the actual physical fibers with the data on the location of the fibers in the topology, you can import it into the HCO, and then you can get the satellite view of your fibers with all the layers on top. And the adapters that we have already supported actually cover most of the networks today, starting with the Cisco CNC. We covered Juniper already. We covered the Cisco EPNM, Cisco NMS for those customers who deployed the Cisco EPNM. We covered Nokia. And for the optical adapters, we covered Cisco, Ciena, Huawei, and Nokia. So that's a very big coverage, I think, of networks today. And on, we're adding more and more adapters when we have more deployments. The last one is actually the multi-domain optical, which is very important because in most of the cases, most of the service providers, they don't have a single optical vendor. They have a few. And if you'd like to show a view of all of them connected together, because in most of the cases, what you find is that you have an optical network, okay, and a termination point between one optical network to another will be either based on Ethernet or OTN. OTN is the equivalent technology to ZR, which is a layer 1 technology. So if you want to see your full optical network with the photonic islands and the termination points as Ethernet or OTN between them, you need HCO4, meaning we're able to show you the full network across different vendors, which if you look at other systems today in the market, which are supporting not only visualization, but provisioning, there are no such systems in the market today. And we have proven integration with all the vendors. And starting with the features of the visualization of the topology, to the provisioning of services across those networks, and the assurance of services across the network. And we have this being implemented, been developed in phases, starting with the adapters that we have today, and coverage of the use cases starting from the next release, which is going to be in November 24. There comes the ITF standard for the layer 3 VPN and layer 2 VPN. Historically, the ITF standard body started with what they call L2SM and L3SM, which was the layer 2 or layer 3 service management. It was a model, a young model of a layer 3 VPN or layer 2 VPN, but it was too high service intent that does not include all the network ingredients into it. Because when it comes to a detailed configuration of a layer 3 VPN in the network, you know that it comprises not only of the service endpoints, which are part of the intent, with the IP addresses and maybe some basic routing rules. It has a lot more. Like, for example, if I would like TE options, I would like to have some underlay tunnel between the service endpoints, or I have many PE to CE configuration that it needed to be covered. That wasn't covered in the original L2SM and L3NM, and then L2SM and L3SM, that they have developed what they call now the L2 network management and L3 network management. Meaning, let's look at that deeper. And that protocol will be actually the data model between controllers in a network, which is more technical than just looking at the service intent. So they have developed these standards, and they were adopted standards by all the players in the IP domain, all the players of the optical of the IP controllers. Us, Cisco, CNC, Nokia, Juniper, they all work with these standards. So what we did actually and maybe before that, I would say that standards are yet immature because not all the cases are covered in those standards. There are many cases, which you can see here, there are still not covered there. Some are related to operational aspects, some are related to the completion of configuration, such as QoS profile management. In many cases, as you know, if you want to cover the QoS, meaning the CIR, EIR, and CBS, EBS of a service endpoint, you need to create a profile, put a profile in the network elements, and then you can get references to the profiles in the VPN configuration. That mechanism is not covered yet in the ITF standards, as well as mapping to underlaid TE, which is very basic today. And in many cases, you need something more robust in order to specify what exactly I mean by TE. It's not only I would like low latency. In many cases, it's even more than low latency. You need some SRLG rules. You need some specific bandwidth. Maybe you need to correlate the service with a specific tunnel that is already there. So such aspects, as well as the inter-ES options, are not yet fully covered in the standards, which, as in case of many other standards, as you know, it's open to augmentations by the vendors. And then we find ourselves in a situation where you have actually an implementation of those standards by the Nokia and controller, and by us, by the Cisco controller. And there is a common model that works with both of them, but not all the parameters are covered. So what we did actually is that we created the model, which is a common model, that the importance of it is, as you can imagine, for a system above the HCO, which are the business systems, the OSSs or the service orchestrator. You can imagine from their perspective, if there is, let's take an example, okay? If we have a service provider that gets a request now from a company to have a VPN between two branches, and they would like to have a VPN. They know the location of the branches. They know the bandwidth they need. They know the latency they need. And those systems, the business systems, they know about the customer. They know about the service endpoints. They don't have to know about the vendor. And they don't need to care about the vendor. From their perspective, the fact that VPN for one customer goes over the Cisco network, or the VPN from another customer goes over the Nokia network, it's out of their control. They don't see it, and they don't need to be aware of it. There comes the HCO, and HCO provides them a generic interface to create a service, no matter what the network is. And this is the common model, because we expose a common model of the standards, of the ITF standards, to the OSS and orchestrator to create a service. And we have the ability to expand this model and send the model with the augmentations either to the Cisco CNC or to Nokia NSP. The aim is, with the time, to enlarge, to increase the model, to add more and more parameters. But the very basic of it, this is the way it works, and it's a solution that is already being in deployment phases these days by one of our customers. I would like to show you how it works when it comes to the user flows. So this is, I would say, a basic architecture of HCO, where you have the applications layer, the engines, and the adapters. HCO has pluggables into the network, which are the adapters, and then there are engines. Engines can be provisioning engines, assurance engine, analytics engines, path computation, and on top of that, there are applications. Applications can be UI applications that are exposed, visualize the network, show the assurance or all the parameters, or RESTconf, NBI, or proprietary REST APIs. So the request comes from the OSS to provision a service. It goes to the application, to the NBI application in HCO, which sends the request actually to an internal NSO component in HCO. And maybe this is a time to elaborate a bit more about that. In many cases, customers would like to stick to the standards when it comes to VPN provisioning. They don't have the capacity now to deal with many customizations. And yet, they do have customizations. So we kind of found a balance between the two. On one aspect, we do provide a solution which is a standardized solution based on the standards, okay? because you want actually to do assurance of a service and you want that solution to be standard for all customers. You don't want to spend a lot of resources not to customize each and every VPN to a different customer. But on the other aspect, you would like to give a room for flexibility to customers, because a VPN in one customer is not the same as another customer. They have different rules for routing rules, for BGP sessions, for security parameters. They are not the same. But what we provide here is the balance between the two, meaning there is a common model. You can take these default common models and work with them. You can create a VPN. You would like to customize it? That's an NSO there. You can take the function packs for the service, which we provided as a default function packs, and you can customize them. Still, we're able to discover the services and visualize them and support all the assurance parameters. So for the provisioning, as you can see, the request comes to the IP provisioning. It goes there to the NSO nets and down to the controllers, because NSO provides also the nets directly to the controllers, which are part of the solution. Now, when it comes to the discovery, we do the opposite. And here you can mind the differences. When it comes to provisioning, we work with the NSO engine to provision the service. Now, NSO engine here does discover the service to reconcile the services and close the loop to know that services were provisioned successfully. But in HCO, we discover the services not from the NSO engine, but from the network directly. We get a notification from the controllers that, hey, service was added. We got this notification. We go and discover the service from the controllers. We get it into the model, into the assurance, and we can visualize now the service. We not only visualize the service, but we also correlate the service to the layers to show you how this service is actually mapped into all the network layers, and also start to collect the assurance parameters, meaning the performance monitoring. I have a slide about that that elaborates a bit more about the discovery, but in basic, this is the way it works. And when it comes to assurance, as I explained before, there is a balance between the flexibility of the solution, meaning the ability to customize the parameters in a VPN, okay, to the way to standardize the discovery of the service. So a brief look at the structure of the L3NM service data, you can see that there are parameters who are actually the core essential parameters of the service. These are the profiles, the VPN service parameters, and the nodes. Okay, this is not changed. Even if you have customization of the service and you would like to augment the model and to add your own rules, your own BGP sessions or whatever, or security, still you get this unchanged. So what we do in HCO is that you can take all this part, you can customize it. In the discovery, we don't look at that. We only look at the basic parameters of the service in order to discover it. We discover those parameters, so even if this is customized and augmented with other parameters, we're still able to get these parameters from the very basic structure of the service, get those into the model, and visualize it. Now, we're still having some gaps in between. I'll elaborate about the gaps later. What are in general the capabilities of the analytics and assurance in HCO when it comes to services? So starting with the service level, we're showing the path, visualizing the path of the service, and we're able also to collect continuously the performance of the UNIs and also the NNIs, but we're correlating the performance of the UNI to the service. So you can see now the traffic utilization of each service endpoint. We collected also from the network level, so you can see also a correlation between the topology and to the service. We have the root cause analysis application, which in case of a failure, you can see what is the root cause for a failure in your VPN. And we collect a history, which is something unique in HCO, which we call time machine, meaning we not only collect information on the multi-layer model, IP and optical, but continuously as we collect more and more information, and as you can imagine, the network is evolving, it has changes, failures, more links, less links. We keep snapshots of the topology every time we have a different view of the network. So there are multiple snapshots being stored in the database. And you can go back in time and see how network was yesterday, 2 weeks ago, 3 weeks ago. This is all kept. And you can get back to it and see how the network was at that point in time. And in addition to the assurance, we have also the analytics and simulations, meaning you can ask yourself questions like, are there any risks in my network? So for example, do you see any point, any failure point, potential failure point, which if an optical link, for example, will be down, there will be several other links in the IP that will be down too. So it's a single point of failure that we can detect that. And you can not only go to the application and ask those questions, there is a process that continuously collects this information and being able to report to you when there are some such risks. In addition, we show you also the relation between layers to assess the link capacity, which is a question many operators cannot really answer. They have a wavelength that they have from one location to another. And now they ask themselves, what is the capacity of this wavelength? Is it close to be full? A lot of traffic on that? No one measures that. Since we have the multi-layer, we're able to show you how many actual tunnels, actual services are actually traversing over this optical link. So it's a good indication for you that soon you may have to increase the link rate or to build another link, which in case of optical planning, as you know, that takes time, sometimes even weeks. And if you want to plan ahead for that, you need this information. Getting to visualization options. So as you can imagine, we have the service path visualization, meaning you can select a service in the UI, you can see the underlay path of the VPN, and you can see it visualized on the map. So you can see the traverse of the service from one point to another. And when you select the path, you can see in green also the optical layer, the optical path between the two. This is where we collect information about the performance and show it in a IGP path analysis, which is a very nice application where you would like to compute a path between two endpoints, just the IGP path, and you would like to see all the links on the path and also the performance of those links. So this is also doable in HCO. This is the continuous collection of the performance which is stored, and in case of finding a path, then you can see the capacity of this path. And the performance application, which has an interesting combination of the performance information, which is HCO is not the expert in performance, of course, okay? You have seen Expedia and you've seen other systems which collects information on the performance. What's unique in HCO is the combining this information with the topology of the network and asking questions like, for example, show me the utilization of all LSPs between one site to another. Or when I look on a lag, link aggregation between two sites, which normally has multiple links inside the link aggregation, are there any anomalies of traffic between the links in the link aggregation group? Which is something that point to a configuration issue or some degradation in the link performance. But you don't notice that because every time you go to any system that shows you the performance, you see the performance of one link. Every time you see a different links. Once you combine it with the topology information, you know this is a link aggregation actually between these two sites. Now you can see the anomaly between the members of the lag. Or if you want to sum all the traffic of all LSPs over a specific IP link. And now you can compare that and see, is there a reason why I see that amount of traffic in this LSP versus this amount in another LSP? That points to many issues that you can find in the network. And as a result of this, combining the information with the topology, it creates a lot of value to customers. When it comes to timeline, specifically about the VPN solution, then is this all available? Well, most of it. We have already the common model service provisioning, which was delivered already in the latest release of HCO, release 8. Integration with the vendors, we did already integrations with the two systems. including the service discovery. There is a gap which is about to close by the end of this year about the underlay mapping of the service to the tunnels, which is an essential part because the core value of HCO, it's actually to provide the view of the path of the VPN from the top layer to the underlay layers. And this part is about to be completed by the end of the year. We must have it because the support in the ITF standard now is very basic and it's going to be augmented by us. We're participating in the ITF and co-share this with other vendors, and we are about to extend the standard there in order to support it. And we do have already the service assurance and the service analytics. This is the end of my session. If there are questions, I will be happy to answer. And if not, moving this to Daniel.
Thank you.
Thank you. Sure. It really depends when you have an optical link that you would like to cover. So for example, if you have source and destination and you need an optical link between them, you can use the legacy optical network. Or if you realize, hey, actually I have a router here and a router there, the only thing I need is an optical 400 gig link between the two. So what you need is just two pluggables that are connected physically to the fiber, and then you have an optical link. Now, that's the beginning actually of the ZR Plus solution, because with the time, you can imagine that what I just described is a solution for a point-to-point link. Say, if I have a router in point A and a router in point B, and I would like a link between them, just a point-to-point link, put a ZR pluggable here and there, you can connect it, you have a 400 gig link. But what if you would like now to have more than just point-to-point? You would like to have a ring of optical link with an edge drop points, which is normally the topology in optical links. And now you can ask yourself, do I need now an optical device to put there? Is there any solution with the pluggables? And the answer is actually yes, which is something amazing on a small form factor pluggable. We have developed another pluggable, which is not the ZR Plus, but a module called QDD ADM, which is edge drop module. So you have pluggable in the router for the ZR. The pluggable in the router have a fiber to the ADM pluggable, which has two links to actually create a ring, an optical ring between the routers, which is actually between the pluggables in all the routers, with an edge drop points. So you can imagine you have now a 400 gig ring between routers, optical ring. So the pluggable actually gets from the routers only the power, nothing else. It's just hosting the pluggable actually. So you can have an optical ring between the routers, and in every router you can decide which are the drop points or end points of getting traffic into and from the ring, which with the time, the aim is actually to replace most of the WDM networks with this solution, especially in the metro areas. When it comes to very complex ones, then you might need ROADMs at the end, which are the cross connects based on wavelength. But in many cases, you can just have pluggables in the router, and that's it. You have an optical link. They are not cheaper, but comparing to an optical solution with a ROADM, it's way cheaper. Yeah, that's the point. Does it answer the question? Thank you.
When you showed NSO as part of the HCO,
yeah.
Does that mean there's when an OSI system pushes a request to HCO that actually lands in NSO? You model that in NSO, or is there some HCO layer in between?
Actually, here there is no HCO layer. The NSO is a component inside HCO. Daniel will elaborate more about the architecture and show how this is actually being deployed there. But when a request comes from an OSS to provision a service, it goes, actually, it is redirected by HCO directly to the NSO. There is no layer in between that translates this request to NSO. NSO has a direct interface northbound to the systems to get it. Now, it works normally with the default function pack that we provide, which we call the core function pack, but it's customizable. Like you can take it and play with it and change it the way you want, unless you don't change, of course, the core parameters as I showed before, which is you have no case to change them. I mean, they're just there. Yeah.
So basically, when you extend the core function pack, this is directly visible northbound because the request is just proxied to NSO.
Right. Yeah. And also in the other direction, like if you want now to get the service service configuration and to know whether this is properly configured, then you can use the same NBI exposed by the NSO to get the service. So for many aspects, you can use the NSO as your service provisioning engine inside HCO. Yet, I would say it is a limited instance of the NSO. You cannot just treat it as yet another NSO that you can do everything with that. It's limited to the core, to the provisioning functions of VPN, and also for the RON, the routed optical network link provisioning, which we use NSO engine for.